What's up, ADC21? I'm Phil Miller. I'm located in Hamilton, Ontario, Canada. That's about an hour west of Toronto. And I'm a Senior DevRel Engineer at Daily. And what that means is I get to work on all kinds of cool stuff, including demos, tutorials, blog posts, and lately, all of our documentation. We've sort of rebuilt that from scratch. For those of you who don't know what Daily is, it's a audio video API company that allows you to build real-time communications experiences. So you could build something like we're doing today based on our APIs, and I'll show you that in a bit. On the musical side of things, I'm a drummer turned synth nerd. I played drums for about 25 years, but over the last few years, I've gotten really into synths, both the normal kind and the modular kind. So here, I want to talk to you today about the web. The web is coming of age. It's become an application platform in its own right. Things that literally weren't possible a few years ago are now possible, and I'm going to show you that today. So first of all, let's talk about video calls. We're all on one right now. I'm sure you've spent a lot of time on them over the last few years, especially the last 2 years. So this is a picture of a picture phone, which I believe debuted many years before, but in 1964, you could go and make a call between New York or Washington or Chicago at a very high cost. I believe it was, several $100s. But let's talk about where we are today in terms of video calls. What I wanted to show you was a video call in the slides I'm using right now, which is possible, but because I'm using all these video devices right now, I can't do that. So I recorded a video of me having a video call in this slide. So I'll just show you that real quick here. This is using Pitch, which is a customer of Daily's. And as you can see here, I'm on a video call in the slides. I can invite my coworkers and you can collaborate in real time in the slides. I know it's a little meta. Next up, let's talk about audio and MIDI. I'm sure everyone here probably knows a lot more about this than me, but this is a picture of an NEC PC88, which, as I understand it, was one of the first computers to have MIDI. That was in 1982. This particular model came out in 1985. I just really like the ad. That's why I used that one. So that's how that started. But today, we can do all of this in a browser. I don't know if everyone is familiar with BandLab. I'm going to click on this link and hopefully it will open BandLab. Maybe not. And of course they are down today. There we go. So for those who aren't familiar, it's a DAW. You can use it right in your browser. You can have MIDI instruments, you can have a drum machine, and it works pretty well. So that's kind of where we're at today. You can have a full-blown production suite in a browser. But what if we combine the two? So if you read the title of this talk, that's what this is all about. We'll get to that. We're going to combine a video call and some music production kind of stuff. But first, a brief detour about online music collaboration and latency. AKA you can't change the speed of light. So there are a few different ways we can deal with latency. The first one is by adding it. I don't know if everyone is familiar with it. There's a product called Ninjam from the folks who created Reaper. And the way it solves this collaboration problem is by adding latency. You specify sort of like a length of a loop, in a number of bars, and then everyone just sort of adds to that loop as it progresses. The next way to deal with latency is by centralizing it. This is a really cool project by some folks in Montreal called Beat Connect. And this is like a DAW plugin where you can just drag and drop tracks into a shared timeline so that everyone has, the same view of a project you're collaborating on. Next, you can minimize latency. This is a really cool project called Jamulus, which allows you to jam in real time. I've heard people get latency numbers as low as 30 milliseconds, 40 milliseconds, which is pretty close to being in the same room. Obviously, you're at the mercy of your local network and your ISP's network and all your peers' ISP's networks as well. So there's a lot of variables there. But it's a really cool project as well. And then lastly, what I'm proposing here is that we embrace latency. But what does that mean? Well, let me tell you. I think the best way to do this is to have a single audio host. And what that means is all the sound is coming from one place. You're not trying to synchronize tracks coming in from different participants. There's one person producing sound and everyone else is consuming it. Make it primarily loop-based because, if you're changing a loop or, a phrase or something, you don't expect that like instantaneous satisfaction of like, pressing a button on a pad on an MPC or something like that. And lastly, focus on things that can feel immediate, even if they're not. So as I said, that's things like changing phrases or loops, via something like a MIDI program change command, or changing sound parameters via MIDI CC. So that could be, like the timbre of an oscillator or, the effects parameter of a delay or reverb or something like that. So this little project that I put together here I call it Web MIDI RTC. We just kind of smashed together WebRTC and Web MIDI, or how I learned to stop worrying and love the browser. So let's talk about the stack we're going to use to build this project. Obviously, this is built on WebRTC, which is an open source project that allows real-time communication applications. This is kind of like a loose set of protocols and APIs, either in the browser or elsewhere. And it's supported in most modern browsers. I say most with an asterisk there because the implementation from browser to browser varies quite a bit. I'm looking at you, Safari. And this is a peer-to-peer protocol, although there are ways that we can scale it beyond, let's say, smaller peer-to-peer use cases. And I'll talk about that in a second. So building on top of that WebRTC, we're going to use Daily, which is the company I work for, full disclosure. And what Daily has built is a set of user-friendly APIs on top of WebRTC to sort of abstract away all that cross-browser complexity. As I mentioned before, Safari is definitely a pain point. So we take the guesswork out of dealing with all those cross-browser quirks. And we also provide global infrastructure to scale those video calls. So a normal WebRTC peer-to-peer call, it's going to get a little hard to scale past, let's say, like 5 to 8 participants, because every one of those peers has to send a track to every other peer. But the way we solve that is by putting a server in the middle. We call this a selective forwarding unit. It's kind of like a super peer. And as you see in this little diagram down here, that's how that scales, because each peer is just sending their media tracks to the server, and then the server is sending those out to the other peers. And because we have this global sort of media server infrastructure, we can do things like recording and live streaming fairly easily. And another big advantage of Daily is using this fully featured pre-built UI. As you can see on the right side here, this is what it looks like on mobile with a couple participants and a couple screen shares. And this is something you can easily drop into an application with just a couple lines of code. I'm actually going to demonstrate that in a bit. And, shout out to our support team. Daily has world-class support, and you get things like call data and analytics, so you can dig in when, if there's something you need to diagnose. And then on the front end, we're going to use Vue. Vue is a UI framework for those who aren't familiar. I like it for projects like this because it's easy to put everything sort of in one component and sort of step through it. I like Vue because it's incrementally adoptable. And what that means is you can just pop a script tag into an existing application and add a little bit of interactivity, or you could scaffold something from the ground up using their amazing standard tooling, the Vue CLI, for example. And lastly, I'm a big fan of their single file component approach. It allows you to see the template, the JavaScript, the interactive parts of it, and the styles all in one place. And next, we're using MIDI because we're going to control some MIDI devices. Web MIDI is the standard sort of browser implementation of MIDI. I'm sure that, like I said before, there's folks here who are probably much more familiar with it than I am. But we're going to use Web MIDI JS, which makes it just a little bit easier to interact with those browser APIs because some of them are fairly low level, and Web MIDI JS just gives us like slightly better abstractions on top of those. Oh, and one more note about that. Obviously, this works in Chrome and Chromium-based browsers. It will work. It can potentially work in other browsers if you install a plugin, but again, it's not going to work in Safari out of the box. And Apple has indicated that they do not intend to implement it. And then the hardware, we're using a couple of cool boxes from Electron here. The Digitact, which is their 8-track drum computer / sampler. It's also its own MIDI sequencer, so you could use it to sequence other devices. We're not gonna do that today. And then paired with that will be the Digatone, which is their modern take on FM synthesis. Basically, what that means is you've got your sort of standard FM synthesis, but you've got subtractive stuff on top of it as well, filters and etc. And that's 8 voices spread over 4 tracks. You can kind of decide how those are spread around. And it's also a MIDI sequencer, but only 4 tracks. So let's have a quick look at our application, quote unquote. So we've got this big white square here. That's where our call will get rendered. We're not going to do that just yet. I'll save that for the demo. But when I click join, you would see, a call UI that would feel familiar to anyone who's used Zoom or any of, the sort of standard video calling apps out there. And then we've got our different UI controls here. As I mentioned, there's a join button. We've got some playback stuff. So that could be, just play and stop. And then different controls for each of the boxes. So the ability to mute and unmute tracks. And then we've got controls over the delay and reverb on the Digatone. In this case, I've wired the output of the Digitact into the Digatone because they each have inputs, and you can sort of pair them well that way. And then the Digatone is sending MIDI transport commands to the Digitact. So then I only need to send one command to start everything, but we'll get into that in a bit as well. Okay, so now let's have a look at the code. Here we go. Can everyone see this? Quick thumbs up. Is that legible? Maybe. Better? Feel like I'm at the eye doctor? Okay. So just the way, as I mentioned before, Vue uses this sort of single file component structure. So we've got our template here, which is basically a bunch of HTML code with a little bit of Vue specific stuff, which allows us to add interactivity. Below that is all the JavaScript, which is how we wire up that interactivity. And then at the bottom is your styles. So that's just, to make it look pretty. And shout out to Jess Mitchell for making this look pretty for me. So let's just step through this a little quickly. We've got a div here, which we call our call container. That was that big white square. That's where the call will get rendered. And I'll show you how in a minute. And then below that, we've got a div that just holds all of our controls. And a little thing here that will play a message when someone clicks a button just to tell you that they've changed something. So if you look at these, it's just a bunch of buttons and inputs. The Vue magic is you can add click handlers, and then the click handler is calling a method which you specify. In this case, when I click the join button, it's going to call join call, which will run, whatever I tell it to. And here we're just binding some state so that we know to disable the button once we've joined the call. And then if you look here on the play button itself, you've got a click handler, which calls control message. And we'll get into the sort of inner workings of how control message works. But basically, that's just a convenience method on top of actually sending the MIDI command. And then the only difference for the sliders is we have a change handler instead of a click handler. So, because that input is variable, we're just going to send the value of that input as opposed to just a static value. So getting into the JavaScript here, we're importing daily.js, which is our library that allows us to interact with daily. In this case, we're using the daily iframe, which is the pre-built UI I mentioned before. We're importing Web MIDI, which is the Web MIDI JS library, which, like I said, gives us like slightly better abstractions on top of the Web MIDI APIs. And then we're importing our message map. So this, let's have a look at this. This is just a way to map from the different commands we're specifying here into actual methods that Web MIDI JS will call. So it's just an easier set of abstractions on top of that. So for example, when I click the play button that we saw in the UI there, it's gonna call send start in Web MIDI JS with no parameters, because that one doesn't take any parameters. And we're gonna send that to the digatone. And remember I said there was a little flash message. It'll display the message, someone press play. And I'll show you how that message gets displayed as well. So that's kind of the nuts and bolts of that. Some of the ones are a little bit more complicated, where you might have parameters based on the type of command you're sending. In this case, like a program change or a control change. In the case of the control change, this is a parameterized function because we're passing in a value. But otherwise, it's all kind of the same shape, if that makes sense. So next up, we're setting up the call. And this is just a configuration object that tells us how to set up the call. There's a few different options you can like enable and disable in the call. Like I mentioned here, we've got a room URL. In this case, I've hard coded the room just for simplicity's sake. This could be created dynamically via a REST API, or maybe you have a preset list of rooms or something. In this case, we're also setting show leave button to true, which just will allow us to leave the meeting from the pre-built UI. And then a little bit of styles just to make the iframe itself look pretty. So just a shadow, some border radius, etc. And setting the aspect ratio. Next up, we're getting into some Vue specific stuff. And again, if you're not familiar with Vue, it doesn't matter. Like it's pretty straightforward. You've got data, which is kind of a way of representing the state of the component. So in this case, we're just initializing a bunch of different state variables, different ones that reference the devices, one where we're saying whether we have local MIDI or not, a list of participants, a denormalized local participant, call frame, which is a reference to our daily API, which allows us to interact with that API. And then some things related to the UI, like we mentioned, the flash message and joined, which will just disable the join button. Next up here is this mounted lifecycle hook. So this says when the component is mounted, run this code. In this case, we're going to call get devices, which will just initialize Web MIDI and then set up the various devices. I'm doing a little bit of a hack here to say, if the digitone device exists, then local MIDI is true. And we'll see why in a bit. Next up, as I mentioned, we had that div where the call gets rendered. This is a reference to that div, and then we're just going to tell it to create an iframe in that div with the options we specified above. And next up, we're going to wire up all of our event listeners, because the way daily works is whenever something happens in the call, like a participant joins or leaves, it emits an event, and then you can wire up a callback to fire after that event is emitted. So in this case, we've got a few standard ones like join meeting. Most of this stuff is just for debugging purposes, just so we can see the events happening. Update participants just updates the list of participants in our state. We're not using that, but in the future, you could display a list of participants as they joined and left. And then when you leave the meeting, we're just going to reinitialize that state to the, initial state. The real sort of secret sauce here, or at least the first part of it, is this app message listener. So Daily has the ability to send messages, arbitrary messages between peers or participants in the call. I'll show you how in a second, but when that message is received on one of the clients, then this callback will run. In this case, we're just going to console log the message so you can see it. We're going to display that flash message that we saw in the UI. And if you have local MIDI hardware, in this case, I do, then we're going to send a control message. And we'll look at how that control message works in a second. So just going back to join call, above when we clicked join, it calls the join call method. The one special thing that's happening here is we're looking for query parameters in the URL. In this case, a parameter called token. The way that we handle user roles in this app is by using daily meeting tokens. A meeting token is a way of just giving a participant elevated privileges and marking them as an owner. So in this case, we are calling join and passing in the token if the token is present. So then you know that this person is a host or an owner. And then if they're not, we're setting MIDI, local MIDI to false. This is just a workaround in case some of the non-host participants had local MIDI devices, which many people might. And we're setting join to true, which will disable that button, if you remember. We already talked about get devices. And we already talked about update participants, which just updates that list of participants. Flash message is, we've talked about that a few times. All that's doing is updating the state with the new message and then clearing that after 5 seconds. So the real secret sauce here is this control message method. And what that is doing, this is what actually sends the message to the hardware. So if you are a host, so for example, if I went into the app and I clicked a button, then local MIDI would be true. It's going to look up our device in the message map, and then it's going to call the method like we talked about in our control map. It's going to call the method in Web MIDI.js with the appropriate parameters. In this case, there's just 2 versions of it based on whether it needs to take a parameter or not. And that's basically it for that. So the way this works, if you're a remote participant and you don't have those MIDI devices, you're going to call frame, which is our reference to the daily API, and call the method send app message, which will send a message that you specify, in this case, the MIDI command. And you can decide who to send it to. In this case, we're sending it to everyone. That's what the asterisk denotes. For everyone who isn't a host, it will just display that message as we talked about here. But for the host, it will actually call the method and send the MIDI command to the hardware. And that is it. That's the meat and potatoes of everything. It all kind of hinges on this send app message method and the handler for that message. And then at the end, as I said before, we've got styles just to make it pretty. Okay, let me switch back. So that's a brief overview of the code. Hopefully, we can do a demo now. So as I mentioned before, if you have a token, that'll denote you as a host. So if I click join, it should allow me, turn on my camera, turn on my device. So you can see my device is here. This is real time. It's not a recording. And then we'll join as a second participant. As you can see, it's reversed. I did that so that the participant wouldn't be reversed. So in theory, if I click play, we should hear some music. Thumbs up if you can hear that in the venue. Okay, great. So this is, this is going through the internet. This is a personal website of mine. And you can see here, I've got it in mute mode. So the lights correspond to the track. So if I mute the kick drum, that'll go away. We take out the hats. And then similarly, on the digatone, I can mute the individual tracks here. You see the lights go off. We can change the pattern. So if you see we're on pattern 1 here, when the loop comes around, it'll switch to pattern 2. Let's unmute those just so you can hear the difference. And then now you can see there's 3 people in the call. I feel like maybe someone has joined, or I've joined somewhere else. But yeah, if anyone in the audience wants to give it a try, yeah, I see 4 people in the call. Some people are joining on their phones, I guess. By all means, play around with it. That's what it's for. You know, 7 people, really cool. I'll just let everyone play around a little bit. We've got 9 people in the call right now. This is awesome. Someone changes the delay time. This is really cool. I think this is the most people have simultaneously done this. So as I mentioned before, there's 13 people in this call. So now we're in sort of that server mode of WebRTC as opposed to doing it all peer-to-peer. Someone stopped it. Yep. Cool. Cool. Well, we could do that all day. I'm just gonna stop it for now. We'll fire it up. So I feel like that was successful. And thanks for everyone for trying that out. I'll fire it up in GatherTown or something after, and we can all play along. So what next? Obviously, that's like a very minimal set of program change commands and CCs. Each one of these boxes has a very full set of parameters that you can control. So we can definitely add more there. We can also add more devices. We're using these 2. I felt like it was a good amount for today, but the sky's the limit in terms of what you can control. As long as it accepts MIDI, you're good to go. In reality, we're only sending MIDI on the local host, but we could do this remotely as well. So imagine a participant had a MIDI controller plugged in, and we mapped some of these CCs to their MIDI controller, which we then sent over the call. That, in theory, is not a problem to do either. And we're using a sampler here, and we have a video call where we're passing media tracks. So in theory, we could also do remote sampling by passing that audio into something like the Digitact. Or, I have a looper pedal that's controlled by MIDI, so we could do real-time looping as well. Additionally, we only had 2 roles today. We kind of had host and participant, but we could have, more granular access to different parts of the app or allow other people to turn their cameras on. The sky's kind of the limit in terms of what's possible in terms of participant roles as well. And one thing that's very apparent after doing this with, I don't know what the peak there was, 15, 16, 17 people, we probably want some sort of command queuing so that they're not stepping on each other's toes. So that could be, allowing one command every 5 seconds or 1 second, or having some sort of token system so that it doesn't get a bit out of control. And then finally, because we're using daily, it's really easy to record and live stream this. It's a single method call to do either of those things. And just talking through this, because I know this is an audio developer conference. A lot of you work for like audio companies. What are some of the practical applications? I just saw a question come in. I'll answer that in a bit too. Interactive live sessions and live streams. We've just kind of demonstrated, like an MVP version of this, but picture, a Twitch stream with hundreds of people. We can make that more interactive using something like this. Additionally, doing remote production, let's say you had something that was a little bit more fully baked and you just want to do that final sound design or the little tweaks. This is definitely a use case for that. The third one here is music retail. This project is actually inspired by Thoman's Stompenberg, which allows you to control guitar pedals over the internet. It's an incredible achievement, and I definitely encourage you all to go try it. They had to, wire those into Arduino or something. But luckily for us, we can just do it with MIDI and USB, and we don't have to solder anything. And then lastly, I think this would work well for something like product launches or previews. You could play a synthesizer that's unreleased or, is in an alpha state just by adding it to the internet. Questions. So I've got one here from Sam. One of the things that gets in the way of some people using some peer-to-peer music making apps is NAT traversal from one network to another. Does Daily's infrastructure provide protocols to have this to solve this problem? Yes. WebRTC has affordances for this via stun and turn. So they should, in theory, allow NAT traversal no problem. It's part of the platform from day one. Joseph says, this was so cool. Thank you, Joseph. Would it be too much to update the UI and browser with changes too? I think it would be good if the sliders updated. Yeah, so the problem there, in theory, it's possible. I kept it simple for now. The problem is the machine doesn't send back state, right? It sort of does, or it might emit CCs if I turn a dial on the machine, but MIDI is a one-way protocol. So if someone updates a slider, in theory, we send that to the machine. The machine probably updates. We can then share the state with all the participants, so they know it was changed. It might not necessarily reflect the state of the hardware, but in theory, it's possible just by sharing the sort of application state. Are there any security concerns with using WebRTC? WebRTC is inherently secure. Daily, for example, is SOC 2 compliant and HIPAA compliant, so your data is protected. I think some concerns I've seen is potentially exposing IP addresses when you're doing, for example, like that NAT traversal, but I'm no internet security expert. But that's something I see that people ask about a lot, say on Reddit, for example.
How difficult would it be to connect this to a DAW instead of a device?
I don't think it would be that hard. You just need something to bridge Web MIDI and your device MIDI. So I believe there are things out there that will handle that for you, but I need to look into that. But as long it's just like bridging MIDI between any piece of software, right? As long as you can do that, you should be good.